Alright folks, welcome back, and we're going to program a game called Ghosts. And Ghosts looks a lot like this. Ghosts is a game where you are a square and you run from ghosts, and your job is to get to the circle. If the ghosts catch you, they slow you down and allow the other ghosts to catch you, and if 3 ghosts catch you, you lose the game. That is Ghosts. What else is cool about Ghosts? The ghosts are aware of what direction you're looking. So you can see here I can freeze the ones that I'm looking at and they won't come any closer in that direction, but as soon as I start moving up, I'm looking away from them. That's kind of a Mario thing. And you can also see that I've positioned everything on the screen randomly when the game starts, so that each game is just a little bit different. What we're going to do today, this is the entire code here. It's not that long, but we're going to do it in parts. I prefer to do it that way so that you guys can see what I had to think through, so I can model for you a little better how this works. And the first thing we're going to do today is make the rectangle character move with the arrow keys. That is the goal for today. So of course, first things first, let's set up our screen. We're going to use void setup. I had a student ask in the last office hours, what does this mean? And this is a little bit more complicated than what we need to get into today. But void means that this function setup doesn't give anything back, which sounds kind of weird because really you'd think, actually, well, setup does give something back. It sets up the whole game. But it doesn't give something back in the same way that, let's say, y equals sine of x. That gives something back. Sine throws a floating point number, a decimal, back into y. We can't say that here. You can't say y equals setup x. That doesn't make any sense. Nothing would end up in y. So we say that setup throws void, or setup gives void, returns void, actually, is the vocab word there. So anyways, let's set up the screen to make our game. Let's make it a reasonably large field here. Let's say it's going to be 900 pixels wide by 600 pixels tall. So that's a pretty big screen. Let's set up the background. Let's make it look a little nicer than mine. Let's make it a nice, I don't know, purple color. A little bit of red, no green, lots of blue. It's going to be beautiful. So we're going to set up the screen here, and now what we're going to get is a screen, and then we're going to run the draw function. Again, it's a void because you can't say y equals draw. That doesn't make sense. Set up the draw function here to draw a rectangle. And we're going to draw it on the screen at some position. Let's start it off in the middle of the screen now, just for giggles. Width over 2, height over 2. And we're going to make it 25 by 25. Okay, so there's our rectangle, and let's see what it looks like. So this is what we've got. A screen that pops up, nice and purple, and there is a beautiful white rectangle outlined in black because we haven't specified fill or stroke. We could if we wanted to. Now we want to make said rectangle move. Remember, draw is being repeated, so what we need to do is every time this gets repeated, it needs to look for the position of the rectangle, which are these two things right here. We have these hard-coded, so they're never going to change. So obviously, we're going to need to put variables in for these two right here. And we're going to give those variables names. And I like to just always call them x position and climax. No, just kidding. See the x position joke? It's an English joke. Yep, you're laughing. I'm laughing too because I have no friends. So we need to declare these variables. So we're going to say x position and y position. Why are they floats? They're floats because we want our box to be able to move smoothly across the screen. We want it to be able to have speeds and things later. So we're going to make them floating point numbers. They could be just integers, but floating point usually allows you for smoother action. You'll notice here that nothing's really happening, though, with x position and y position. They're not going to change. In fact, they're not even set. So the box isn't going to end up anywhere on the screen. In fact, we might want to actually set these when we create them. So we've declared them here, but we can actually also initialize them or set them here. Let's put them randomly between 0 and width. And let's set it random from 0 to height. Okay, let's see what that does. Oh, we have it at 0, 0 here. That's a convenient thing. Let's check it again to see if our randomization has worked. Oh, it isn't. Do you see the problem here? This box isn't being randomly placed, and that's because we're asking for the width and height of the screen before we actually set it. So you can see here that the size of the screen is set right here, and we're asking to use it beforehand. The computer doesn't know, so it's just sticking a 0 in here. And I dare you to pick a number between 0 and 0, and I know I'm always going to know it. In fact, I'll bet you $1 million you're going to pick 0. So this isn't going to work the way we wanted it to. So let's get rid of that. And let's put that in down here, in fact. I wonder what happens if we put it right here, before the draw function. Do you think it will still work? So x position equals random from the 0 to width. And the y position can be some random between 0 and height. I wonder if it knows now. Curiouser and curiouser. Oh, it doesn't love the idea of this. I wonder why. Interesting. Curiouser and curiouser. And I think it has something to do with the fact that when you're using setup and draw, you really need to do all of your work inside of these methods. You know, when you want to use draw, it needs to know what code you want to repeat. And you kind of confuse the program if you put some code in the sort of interstitial space here in the middle. So we're going to set these randomly in the setup function, which is obviously where we should have put it in the first place. You know, it's called the setup function for a reason. And here we go, random 0 to height. Whoops, semicolon. Semicolon is just like a period at the end of the sentence. Someone asked me why they chose semicolon. It's because no one uses it hardly at all. Now we're getting a randomly placed box. Let's prove it. As long as it doesn't show up in the same spot, we know it's random. Bingo. Look at this. Beautiful coding here, children. Beautiful. We're moving along. But this doesn't really do anything because we can't change this variable and this variable very well. So we need a function that actually is going to change these variables. And because we declared them up here, this makes them available to the whole program. Okay, that's important. So now if we use another function, which we're going to use, called void keyPressed. Again, keyPressed doesn't return anything. It just does something. If we use this function, for the love of Pete here, okay, void keyPressed is a special function. You can see here because it gives it a color. You know, if I type in my own random function, let's say a function that returns an integer called waffles, you can see here that processing doesn't respect it. It doesn't give it its own color because I'm making that function up. Keypressed is a very special function. Keypressed, oops, it has to be capital P. Keypressed looks for, surprise, surprise, a pressed key. Okay, and there's a special variable called keycode that you're going to use inside of keyPressed. These are all built directly into processing, just some of the basic stuff you ought to know about it. And so how does keyPressed work? Well, it looks for a number, it looks for a key, and when the key is pressed, it throws that to the program and says, hey, here's the key. What do you want to do? And we'll say, well, if the key, in which case we call it keycode, if that's the same as, that's what these mean, if that's the same as, let's say, up, then let's move the y position. We're going to take y position, and we're going to take, you know, I don't know, whatever, half a pixel off of it if you press up. So let's test that. So what's going to happen is I hit this this method, if I hit up, move it up the screen, but draw is randomly redrawn, or not randomly, but regularly redrawn. And what I'm doing is changing this bit of memory here so that when this function goes to look for it, it's down by a half from where it used to be. So let's run this. Now if I press up, hopefully I ought to be able to move my guy. And I can. You can see here it's a little bit sluggish. We'll have to mess with the frame rate and things like that. But the guy can move up now. Hit, 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 hit. We might need to redraw the background a bit so that we don't see it every time. So every time draw runs, we need to redraw our background. 200, 0, 150. And we can add the if statements for all of the other keys as well. And then we'll be done with this video here. Simple as that. So just an if for every key you want it to respect. If the key code is down, we're going to add a pixel. Remember, down is away from 0. If the key code is left, we're going to subtract from the X position. If the key code is right, oops, don't want to screw this up, change them all to X's. If the key code is right, we're going to add to the X position. And now you can see we have a fully movable dude who appears to be his own sprite on the screen. Up, 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 up. Left, 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 left. Mighty sluggish, but we'll fix that next time. To the right here, down. Isn't this just the most thrilling thing you've ever seen? Not quite ghosts yet, but we're getting there.